Solve quadratics by finding square roots. Before we begin this lesson, let's review. Now, you may be groaning right here and you may be saying, why are we reviewing again? Well, for the last 3 years, each of my classes have flunked this one test, and we've had to stop and then reteach. And that takes about 6 weeks for this chapter. So, I'm trying to review a lot so that you guys really know what's going on so that we can get through this chapter the first time. Okay, so let's review. If we have a quadratic, how do we know it's a quadratic? Well, we know it's because we have some sort of x squared term. And that's what makes it a quadratic. If we took out the x squared term, we just have a linear equation, right? But once we have the x squared term, it'll graph as a curve. And what's the curve called? It's called a parabola. Parabola has a vertex, and it's either the lowest or the highest point of the quadratic. It has an axis of symmetry, which the vertex is on. The axis of symmetry means that there's a mirror image point for every point that's on the parabola. So, let's go ahead and find the axis of symmetry for that. Do you remember the equation for that? It's x equals negative b over 2a. Now, what's b? B is the number in front of the plain x term, along with its sign. So we have negative 4. And then, what's a? A is a coefficient in front of the x squared term. If we don't have one, that means it's automatically a 1. Now, what's negative 4 divided by 2 times negative 1? That would be a positive, because negative divided by negative is a positive. Positive 2. Now, that's the up and down line. That's the symmetry. Now, the vertex is somewhere on that line. But where? We need to find the y value of the vertex. And the way we do that is by substituting the x value into the original equation. Now, since a negative's outside the parentheses, I need to square my 2 first. So 2 times 2 is 4. So negative 4. Minus 8 minus 5. That would put my... Gosh, and I've already made a mistake. Did you catch that mistake? When I said negative b, what was b? B was negative 4. So I need another negative over here. What would that make it be? That would mean that this is negative 2. Okay, if I put a negative sign here and a negative sign here, how does it change this? Well, this is still negative 4, because negative 2 times negative 2 is positive 4. Positive 4 with a minus sign in front of it is negative 4. But this is going to change that sign, isn't it? Instead of negative 8, we're going to have positive 8. Okay, so negative 4 minus 5 is minus 9. Minus 9 plus 8 is negative 1. Okay, that means our vertex is at the point 2, -1. Our line of symmetry is the 2, -2, sorry, and it opens down because my A value is negative. What else can I say about this? Let's see, the y-intercept would be -5. So let me move this up and get some free space. And then let's go ahead and graph this. So here's my line of symmetry at -2. My vertex at -2, -1. It opens down. Okay, I can't really tell where, well, I know the y-intercept, don't I? Is at -5. So I could put that point in. And then my mirror point over here. And I could get a pretty good graph from that. Again, it would be nice if I took one more point with the equation. But for this purpose, that's good. Now, does this have solutions? So what are the solutions? Remember everything that I'm asking for about solutions? That means I could also be asking what's the x-intercept, what's the roots, can't think of the other one right now, but I'm asking all the same things in here. Where does it cross the x line? Well, it doesn't. So there are no solutions. Now again, that's kind of a simplistic way to answer that, because we could better say there are no real number solutions to this. There's nothing that I could put in for x that would make y 0. So, okay, that's quadratics in standard form. Let's look at them in factored form. Okay, if I have y equals x plus 3 times x minus 2, then how does that graph look? These are the roots, are the x-intercepts. So if I set both of these equal to 0, that means my x-intercept is +2 or -3. Here's that. 1, 2, 3. Here's that one. So this is where this graph would cross the x line, or my solutions to it. Now, if I want to actually graph this, how do I find the line of symmetry for this? Well, I could either FOIL it back and then use my -b/2a, or I know that these are mirror images of each other, so I could just average these two and then find the middle line. So if I add 2 plus a -3, that would give me -1. To average them, I need to divide by how many terms I have. So take that -1 and I'm going to divide by 2. That'll give me negative 1/2. Okay, so does that look right? Yes. That's my line of symmetry. Now, to find my actual vertex point, I need to put my negative 1/2 in for x. So let's put it back in the equation. Y equals negative 1/2 plus 3 times negative 1/2 minus 2. So y equals, what's 3 minus 1/2? 2.5 or 2.5. And then what is negative 1/2 minus 2? Negative 2.5. Okay, if I multiply those out, I will have, let's see, negative 6.25. So somewhere down here is my vertex. Alright, so to graph this, I would make a nice smooth curve like this. Okay. That's called intercept form. Okay, this is called vertex form. In vertex form, I could multiply it all out and then go back to my negative b over 2a. I'm not going to do that all the way, but I need you to make sure that you know that x plus 8 squared equals x plus 8 times x plus 8. Okay, and so you would have to multiply these two terms out using the FOIL method. Be really careful, make sure that gets in your head. It's not just x squared plus 64. You'll have a middle term there. Now, I could do that, but it would take lots of math, so that's not my preferred way of doing it. So, I'm going to go ahead and draw a line through here, because I want to try to do it the easier way. And then what's the easier way? Well, it's to know what my H and K form is. If I have the equation in this form, then I can just pull off the vertex, and it's HK. Okay, now compare this form up here to this one. What's wrong? Well, that sign's not right, and that sign's not right. So I need to try to get it into that form without actually changing the value of anything. So the way I do that is changing that positive sign into a negative. If I cleaned up those signs, that would still be x plus 8. So it's still legal in algebra terms. And then I need a positive here, but I need to keep that negative. So again, it would turn back to a -3 if I cleaned up my signs. If I do that, then I can read this HK straight off. So my vertex would be the ordered pair -8, -3. All right, with my line of symmetry being -8. Now, if I need to graph that, one of the easiest ways to graph that would be to go ahead and put a number in for x. That would be very easy. So let's stick a -8 in for x. Well, and it already is a -8, huh? So let's go ahead and pick another easy number, And let's put a negative 7 in for x. If I did that, then I would have y equals negative 2 times negative 7 plus 8 squared minus 3. What's negative 7 plus 8? The positive 1. What's 1 squared? 1. 1 times negative 2 is negative 2. Negative 2 minus 3 is negative 5. So I would have one point here, and then I would have a mirror image point. To make a better curve, I could stick another number up here for x, say a negative 6, and figure out what the y would be for that. All right, now let's go on for today's lesson. Okay, before we actually talk about quadratics, we need to talk about square roots in this lesson. So here's some properties of square roots. If I have a square root of any number, a, b, I can pull that apart. I can say that's the square root of a times the square root of b. I can even go backwards and put them back under the square root if I need to. Let's see how this works. If I have 12 here, it doesn't look like I have an a and b, but I know that 12 is 4 times 3. So I can break that up into the square root of 4 times the square root of 3. Well, I could further simplify square root of 4 into 2, and then times square root of 3. So that would be the simplified version of square root of 12. Now, if I have the square root of, let's say 8 times the square root of 2. Well, since they're both square roots, I can do the backwards thing and say that equals the square root of 8 times 2, which is the square root of 16. And we know the square root of 16 is 4. Okay. Now, this also works for division. So if I have the square root of 1/4, I can say that's the square root of 1 divided by the square root of 4. The square root of 1 is 1, square root of 4 is 2. Let's do that again with the square root of 1/2. So I can break that apart into square root of 1 over square root of 2. Square root of 1 is just 1, but square root of 2 is not a nice number. Now, that's the proper value for the answer, but it's not correct in terms of math grammar. Math grammar says that I can't leave a root on the bottom, so I need to get rid of it somehow. But I can't just erase it because that would be changing the value. So I have to do something to this to get rid of my root on the bottom, but not change the value of what this is. And the trick is that I need to multiply by that root as a fraction, top and bottom. Because if I do that, I know that any number divided by itself is 1. And any number times 1 is just that number. So if I multiply by that, I'm not changing the value any. What's 1 times square root of 2? Square root of 2. Now, square root of 2 times square root of 2. Anytime that I multiply a square root times itself, I can just get rid of the square root sign. That's just plain 2. Because you've learned up at the top that I could put that under the same square root sign. So the denominator would equal square root of 4, and we know that's just 2. So if you see a square root times itself, just drop the square root sign. And that would be the answer. Now, we call that simplified version, but technically it doesn't look much more simpler than what we had to begin with, but is grammatically correct. Okay. There is another time in a different situation that you'll have to simplify this. Now, for these, I can't just multiply by square root 2 over square root of 2, because that would be fine for the top, but I would get 7 times square root 2 plus 2. That doesn't really help, does it? I still have a square root of 2. So instead of doing that, what I need to do is use this trick. I need to flip the sign and multiply by top and bottom by the same thing. What does that do for me? Well, you know that the middle term will drop out on these. So let me show you that. What's 7 times 7? It's 49. And then negative square root 2 times 7 plus 7 times square root 2 minus 2. Okay, and let me go ahead and flip this around so that you can see it a little better. So 7 square root 2. You see that these two terms would cancel each other out? And so I would just be left with the whole number of 47 down below, which is good. I've gotten rid of all my square roots. And then let's go ahead and multiply this out top. So instead of 3, I will have 3 times 7, 21, and then minus 3 times square root 2. So that is the grammatically correct version for this problem. Okay, now let's get into the real lesson. If I have a quadratic that doesn't have a plain x term in it, there is a way that I can solve these by taking the square root of both sides. The way I need to proceed on this is to isolate x squared on one side of the equation. So I need to go ahead and subtract 5. And that would give me 3x squared equals 36. Divide by 3. X squared equals 12. Now, here's a trick, or not a trick, but something that you just have to know. I'm going to change colors so you can really see this well. If I draw a square root sign to solve this, there's something special I have to remember to do. And that's to put a plus minus in front of the square root. And you'll see why in a moment. So, what's the square root of x squared? It's just x. Let's go ahead and simplify the square root of 12 say it's 4 times 3, which would be plus or minus 2 times the square root of 3. Okay. Now, let me show you why that plus or minus works. If I was going to put that back into my equation, into the x squared spot, if I put a negative here, do you see how when I multiply that out and square it, that will be a positive. So I have two answers. It can either be the positive version or it can be the negative version here. So it's really important to get both of those answers. So one more time, if you draw the square root sign on both sides of the equation to solve, you have to put a plus minus in front of it. Okay, let's do one more example just to make sure that we've got it. So if we have 1/5 times z plus 3 squared, and if that equals 7, then what do I need to do? Okay, let's isolate the squared part of it. So first, I need to take my z plus 3 squared, and I need to multiply both sides by 5. That will mark out this and give me 35 here. Now, I can go ahead and get rid of the square term by taking the square root, remembering to put my plus and minus there. What's the square root of z plus 3 squared? It's just z plus 3. Now, can I do anything with 35? No, because I could break it up into the square root of 7 times 5, but neither one of those has a nice square root, so I'm pretty well stuck with that. But I still don't have z by itself, so I do need a minus 3 from both sides. So I will have z equal to -3, and they usually put the plus minus term at the end. And that's the answer.